Hi guys and welcome, grade 12 Mindsetter to Learn Extra Live Maths. Finally we're back and I know that you've all been missing us terribly. Kashifa, we are back. I told you we would. 2 weeks. 2 weeks is nothing. So guys, tonight's show is brought to you by Liberty. Thanks guys, you guys rock. Tonight our topic is transformations with Liesel. Liesel, chat us, tell us about it.
Okay, now Indiana and Mindsetters out there, basically what we're going to do tonight is we're going to go, and this is a grade 12 topic only, we're going to have a look at how to rotate a point through any angle. So starting in grade 10, you guys have learned how to reflect in the x-axis, how to reflect in the y-axis, how to rotate a point through 180 degrees, and to know what the new coordinates are. Now we're going to have a look at every single angle under the sun. 60 degrees, 50 degrees, 120 degrees. We're going to show you how to obtain the new coordinates using the formula for rotation through any angle.
Exactly. So guys, hope you're all tuning in, and don't forget, next week our topic will be functions and graphs. Lots of you have been asking us about our schedule, so if you are in the group, the topic next week is functions and graphs. The show tonight will start off with transformations, and after the break we'll be working through an example or two. There are lots of ways to get hold of us: facebook.com/learnextra, chat to us on Twitter @learnextra. So while you're watching, shoot questions off to us and we'll get round to them in the third part of the show. I do have a Casio calculator to give away. We will be announcing the winner on the page tomorrow. So guys, get your questions in, get your comments in. It could be anything. Maybe it's even an inspirational quote. We don't mind. And so after the break, we'll be back with Liesel. We've also got some exciting news and an amazing giveaway for you. So don't leave those seats. Be back with you now. Hi guys and welcome back to Learn Extra Live. Finally, the moment you've been waiting for. I know for the last 2 weeks you guys have felt completely lost. Finally, you have been found. Learn Extra Live is back. And Liesel is with us and we're going over transformations. So stick to your seats, get your pens and papers out and get ready to learn more and learn extra. Liesel, take it away.
All right, guys. So as I was telling you before the break, what we're having a look at tonight is how to get the new coordinates if a point has been rotated through any angle about the origin. Now, this formula is on your information sheet. Now, in fact, there are two formulas. There's one for when we rotate in a clockwise direction, and there's one for when we rotate in an anti-clockwise direction. I am going to work with the formula that works with anti-clockwise direction, and I'll just show you how to adjust it. So let's quickly have a look at this formula. You don't have to learn it because, as I said to you guys just now, it is on your information sheet. Right. So, our new coordinates x and y are given by the following. Now, I seem to be struggling a bit with my pen over here. Right, that's a bit better. Okay. So, to get the new x coordinate and the new y coordinate, after you have rotated a point about the origin in an anti-clockwise direction, here's our formula. Right, so the new x coordinate is calculated as followed. I take the old x coordinate. Now, Indiana, I don't know what's happening here, but our board is...
Stick to that yellow pen.
Okay, so there we go. No, still not.
Click the there you go.
Right, so let's have a look, see if that's a bit better. Sometimes makes you think that old-fashioned blackboards are the way to go.
A stick of chalk and a chalkboard.
Okay, we're going to try this one more time, otherwise we're going to have to go to a break while we quickly fix this. Okay, guys, I'm really, really sorry. I have to write the formula down for you guys in order for us to see what's going on, and I just can't seem to get the pen working at this moment. We're going to try one more thing, and then we're going to have to go to a break.
Let me take you to a break, Liesel. How's about that?
Okay.
Okay,
well,
guys, what we're going to do is while we get our gremlins fixed and we're going to take you to a break, I just want to chat to you about quickly who's on the page. Tabanga said, I just practiced grade 12's transformation yesterday and today, and I'd be interested to see what I did and what I don't understand. And then Bali says, so glad to be back. And Bali, so glad to see you. Sini Temba, I'm here, excited about the topic. Tatu Indiana, please can you ask Liesel, we can get a math study guide. And I'm going to tell you exactly where you can get a math study guide, guys. I'm going to post a list of all of our mindset textbooks so you can check those out. Also, don't forget that we've got a very exciting giveaway happening a little bit later, which we're very, very excited about. I also wanted to say well done to Kaklejo. That was a fantastic first session on Mindset Learn Extra. And thank you so much, Mindsetters, for being so fantastic and so accommodating and so welcoming. Team Mindset all the way. We're going to take a quick break, and we'll be back with you shortly in a second. Hi guys, and welcome back to Learn Extra Live. This is Maths Grade 12, and I hope you all had a fantastic holiday. In fact, I want to hear about your holiday. Let me know on the page how it was, what you did, were you learning more, were you learning extra, and I hope that you all relaxed and had a really nice holiday, because that's what you need. You need to refresh yourselves, get lots of sleep, drink lots of water, give yourself lots of time to study. Timetables are awesome, guys. Set your times so you know when to study. That's the best tip I can give you for today. So guys, today we are chatting about transformations with Liesel. So if you do have any questions, please make sure to send them through. We will be going over them in the last 15 minutes of the show. Big shout out to Liberty for making this awesome show possible. Keep your eyes peeled for an exciting announcement during the show. This is going to be a cracker of a show. So let's get to Liesel. Liesel, take it away.
Right, so we seem to have our board fixed, so that's really great. Okay, guys, so as I was saying before, we start off with a point, right? So if I can draw a system of axes here, let's say we have a point over here, we call that point A. Now I say to you, that point is rotated through a particular angle, either clockwise or anti-clockwise. Now this formula, as it is here, works for both. I'm going to show you guys what to do. Anyway, we take anti-clockwise to be normal. So I'm saying I've got a certain coordinate over here. Then I rotate that coordinate through the origin in an anti-clockwise direction to a new point. And the angle can be given as whatever. So I can say it's rotated through a 60-degree angle, through a 50-degree angle, through a 90-degree angle. We can then use this particular formula on the board to calculate the new coordinates. So let's see how it works. Right. So the formula says to us the new x and the new y coordinates can be calculated as follows. I need xa, that is the x coordinate of the original point before rotation, multiplied by the cos of the angle that we have rotated through. So let's say we rotated through an angle of 60 degrees in an anti-clockwise direction. I will say the original point multiplied by 60 degrees, right, minus the original y coordinate multiplied by the sine of that angle. Now, this entire section here, so my entire first line, the answer to that will give me my new x coordinate, okay? Right, then the y coordinate, I need the original y coordinate multiplied by the cos of the angle that I rotated through, plus then the original x coordinate multiplied by the sine of the angle that I rotated through. And this will then give me my new x coordinate and my new y coordinate. Now the formula, as it is written here, is for anti-clockwise rotation. So if I rotate through 60 degrees anti-clockwise, my angle alpha there will be 60 degrees. However, you don't have to know two different formulas. If we are rotating through a clockwise direction, all I do is I change the direction of my angle. So let's say, for instance, I say I am rotating through 80 degrees clockwise, then you are just going to change the direction to a minus. Right. So this is the basic formula that we are going to be using. Now, there's a couple of different ways in which questions can be asked. The easiest type of question is when we are given a point to start off with, we are given an angle of rotation, and we are asked to calculate the new coordinate. So let's start off with a question such as that one. Right, so let's say I am starting off with a point B, let's call it point B. And the coordinates of point B, let's make it in the first quadrant, are x is 2 and y is 3. Right, so x is 2 and y is 3. We seem to be having trouble with our pen again. Right, so that is where we are starting off. So imagine that now for yourselves. We are working here in the first quadrant. If you draw a system of axes, x is 2, y is 3. Let's say it's over there. Now, I'm going to rotate this point in. Okay, so let's just connect that with our origin. So now, that's B over there. So B is there at the end of my line. So now I'm going to rotate B through an angle of, let's say, 60 degrees anti-clockwise. So that means I'm going to be moving this terminal arm in a 60-degree direction that way. So this angle between the original point and the new point is 60 degrees. Right. So the question is, so we're given the original point B, that's 2, 3. We are given the angle of rotation, that's 60 degrees, and we are asked to calculate the whatever. We can call it B or B dash or whatever. So I'm now going to have a look at how to apply the formula. In the meantime, though, Indiana, what are
Questions?
questions out there? Yes.
Okay, guys, so what I'm going to tell you to do today, because things are acting a bit difficult, well, our pen's being a bit difficult with us. So, guys, please send in your theory questions with what Liesel has been chatting about. I'm about to pull her next to my computer screen, and we're about to go over all of your questions, so get them in now. But while we're talking, let's see if there's anything that's happening. Yes, Masabata, she says, seems like the board is still on holiday. Ish, I like that. That's exactly what's wrong. The board is on holiday. That's exactly. Okay, from Nkalala, said, is that formula of finding the coordinates or of the rotated point provided in the data sheet?
Yes, it is,
Is that a good
Indiana. And
question?
in fact,
Yes.
these days we are given two formulas, one for anti-clockwise and one for clockwise. But guys, the formula that I've written on the board is the anti-clockwise one. So if your formula sheet or your data sheet has two formulas on, this will be the first one. I always use this one. And what I said before is if the rotation, the direction of the rotation is then clockwise, I just changed the direction. Okay, so you do get this formula. Indiana, I'm glad to see that people are watching us.
Yeah.
So basically the question so far is B is the point, X is 2, Y is 3, and we are rotating in a 60-degree anti-clockwise direction, and we want to now calculate the new coordinates. So I'm quickly, before we go to a break, just going to go through how to apply the formula. Now, the formula started with XA cos alpha. So XA means the original X coordinate. So XA in this case is 2. Okay. Then it says cos of alpha. So that is cos of our anti-clockwise rotation. So that's cos of 60 degrees. Okay, this is all still to calculate the X coordinate, right? Then it says minus, and then YA. Now, YA is our original Y coordinate, which is 3. And then sine 60 degrees. Now, it's important that you guys notice that this entire 2 cos 60 minus 3 sine 60 is only to calculate the new x coordinate. Okay, so we will then put that into our calculator, and that will give us the new x coordinate. Right. Then, to get the new y coordinate, and I'm just going to do that underneath, we start with the y value of the original point, which is 3. We multiply by cos 60, and then plus, and our original x coordinate, which is 2, and then sine 60. Okay, Indiana, so what I'm going to do is, while we go to a break, I'm going to let our guys take out their calculators. In fact, guys, you don't really need a calculator for this because, of course, 60 degrees is a special angle. And remember now, the first line over here will give you your new x coordinate. The second line will give you your new y coordinate. Now, just a quick tip. This is quite a lot of work, and you've got to do quite a lot of substitution. But some people battle to remember the easy rules, like the 90-degree rotation and the 180-degree rotation. Guys, if you're unsure, you can use this formula for absolutely any rotation. So even the ones that you are meant to know off by heart, you can just substitute values into here, and that way you can make sure that you do it correctly. Right, we're going to take a short break. Indiana, what are the kids out there saying to us?
Well, actually, I think you might have just answered this, but you know, sometimes I even need a little bit of clarification. So this is from Londiwe, and I think it refers to what you're just talking about. She says, can you use that formula to calculate the angle if not given?
You can. Yes, you absolutely can, and that's the hardest type of question. However, we're dealing with 3 things here. Original point, angle, and new point. So out of those 3 things, we need to be given at least 2. Okay, so if they give us the original point and the point after rotation, we can calculate the angle, and we are going to do one of those a bit later on. It does involve a little bit of simultaneous equations and manipulation, but we will get to that, definitely.
Okay, cool. Okay, now this one is just a little bit of clarification from Anele. Anele wants to know the clockwise is negative and the anti-clockwise is positive.
No, anti-clockwise, we use the positive angle. So if I say to you 60 degrees in an anti-clockwise direction, you put in 60 degrees. If I say to you 60 degrees in a clockwise direction, then you put in a minus. Okay, so clock is negative, anti-clock is positive.
Okay,
right?
Here's a good one. Okay, this is like throwing like a cog in the works. Sedimo says, can you use the same anti-clockwise formula for a clockwise rotation? Example, if they say 60 degrees clockwise, can you just say that it's 300 anti-clockwise?
Yes, you can, because of course it's a circle. It's the same position. He's absolutely right. So what you do is you take whatever you need to add to... So guys, just to clarify what he said, instead of saying 60 degrees in an anti-clockwise direction, 60 degrees in a clockwise direction, what was it, Londiwe? He said yes. 300 degrees in the other way, that's also fine. So what you can also do is if you don't want to work with the negative angles, you can just have a look at what do you need to add to that angle in order to give you 360 degrees. That's fine.
Okay, cool. So guys, what I think we're going to do is we're going to take a little short break, but what I need you to do is I need you, grade 12s, you guys the big kids, you guys the top dogs and the top bosses of the school, please, please, please post questions onto the page about what Liesel is actually chatting about. So let's get some good questions. Let's get ones that everyone is wondering about, because you know, sometimes when you think that you're wondering about a question, you probably have 1,000 other learners that are wondering the exact same thing. No such thing as a stupid question. So get those questions in, and we'll see you straight after the break. Hi guys, and welcome back to Learn Extra Live. This is Maths Live with me, Indiana, and we're back from holidays. We're so glad. So guys, I hope you saw Kaklejo earlier. I think she did a fantastic job. Just let you know, the Ty's not gone, I'm not going. Team Mindset is only getting bigger and better. So I hope you dig in and liking it. I think what we're going to do is we're going to get straight back to Liesel, but before I do that, I want you guys to send in lots and lots of questions. In the last 10 to 15 minutes of the show, I'm going to have Liesel standing right here next to me, looking over my shoulder and looking at the posts that you are posting on the page. So I just want to give Sedimo says, thanks, Indy. Oh, by the way, I'm a she, and my name is pronounced Siadimo. Giggles. Siadimo! Yes! Finally. Thank you. I'm sorry for pronouncing your name wrong. I'll never get it wrong ever, ever again, I promise. So now, without further ado, let's go back to Liesel. Liesel, take it away.
Okay, so I'm just going to do another pretty straightforward question where we are given the original coordinate and where we are given the angle, because I'm finding there's a lot of questions coming through. You guys are not 100% sure, which is fine. This is the first lesson that we're ever doing. Again, guys, I apologize. As Indiana and one of our viewers was saying, the pen is still on holiday. Right, but we're doing the best we can, and let's have a look at this question. It says, determine the image of A, which is the coordinate where x is -2 and y is -√3, after a 210-degree clockwise rotation. Now, guys, I think it's very important to just visualize what we're dealing with. What we've got here is a negative x coordinate and a negative y coordinate. So we are in the third quadrant. Do you guys agree? Hope so. So what I'm saying is, there's my negative x-axis, there's my negative y-axis. My point is somewhere over here. Well, so let's just say, let's say over there. Now, I am rotating in a clockwise direction. So in a clockwise direction is like your clock, hence the word clockwise. And that rotation in the clockwise direction is 210 degrees. So what I'm visualizing for myself is I'm starting off with a negative coordinate and negative x coordinate and a negative y coordinate. Now, if I rotate through more than 180 degrees, it makes sense that I would be in the first quadrant once I'm finished. So the answer that I'm expecting, I'm kind of expecting a positive x and a positive y. I have to emphasize that it's very, very important to think about what you're doing and even draw yourself a little diagram so that you don't make silly errors. Sometimes we get nervous in an exam, you guys just punch any old thing into any old formula, and you don't take that couple of seconds just to look back and say to yourself, is this realistic? Okay, so anyway, that's what I'm expecting, and I'm now going to start off with my formula. Now, as I said earlier on, I use the same formula the whole time, okay? All I do is if it's anti-clockwise, I make the angle negative. So let's get going. So to get our new x-coordinate, we have to take our original x-coordinate, which is -2. Then we've got to multiply it by the cos of our angle of rotation. But because my angle of rotation is, because it's clockwise rather, I am now going to make it minus. You can also, as one of our viewers suggested earlier on, what you can also do is you can just take whatever you need to add up to 360. So 60 degrees, make it 300, whatever is less complicated for you. Right, let's get this pen going here. So cos, and now I'm going to write negative 210 degrees. And not that we mind your questions, but before you all start saying, why is it minus 210 degrees? Because the question said clockwise. If it was anti-clockwise, I would have stuck with the positive answer. Okay, I'm not finished yet. Then minus, okay, there is a minus on the formula, and then multiplied by the original y coordinate, which is negative square root of 3. So I'm going to put that in. Negative square root of 3. And that is then multiplied by the sine of the angle of rotation. And again, it's negative, not because of the direction. Okay. Now, guys, what I've done here is I've calculated the x-coordinate. I haven't gotten around to the y yet. So what you can now do it depends. You are allowed to use your calculator, so it doesn't really make a difference. I can add 360 degrees to the 210 degrees to make it positive, whichever way you want to. I'm going to do it like that. So I'm going to say this is now negative 2 cos 150. Okay? Guys, why am I allowed to add 360 degrees? You might say, why is she just randomly adding 360 degrees to minus 210? Because of course, guys, if you turn 360 degrees around, you end up in the same position. So I've just made that angle positive. So it's negative 2 cos 150, and then plus, because the minus and the minus give us a plus, root 3 sine 150. Now, guys, both the 150 degrees are all special angles. So I don't know if you guys are going to actually do this, but we can say that cos of 150 is, of course, 180 minus 30. That is in the second quadrant. Cos is negative in the second quadrant, so it gets a minus, and together with that minus, that gives me 2 cos 30. If you don't believe me, you can just use your calculator. So that's 2 cos 30. Then sine 150, that's also in the second quadrant, but of course sine in the second quadrant is positive, so this just changes to root 3 sine 30. Okay. Looks like a lot of work. It isn't really that much. Then you fill in your special angles. The cos of 30 degrees is root 3 over 2. The sine of 30 degrees is a half. Then I'm going to allow my calculator, I think, to add these together. Let's just have a look there. And the final answer, and I know this looks like a lot of work, but I have stretched it out a little bit. The final answer for my x-coordinate, and this is my x-coordinate only, is 3 root 3 over 2. Okay. Now, 3 root 3 over 2 is positive, so as I expected from the beginning, if I have a look at my rotation here, I expected my answer to be in the first quadrant, and at least the x value is in the first quadrant. So far, so good. Now, guys, this is just to calculate the x-coordinate. Now, I'm going to emphasize, in an exam situation, you would only show all of these steps if for some reason, if the instructions said you're not allowed a calculator. Otherwise, guys, I would have at that point already typed it into your calculator. That's absolutely fine. Okay, so read the instructions. That's really, really important. Okay, now I need to calculate the y-coordinate in a similar fashion, and I'm going to do that quickly. Let's have a look. I don't even want to say this out loud, Indiana, but it looks to me like our pen might be behaving a little bit better. All right, so our new y-coordinate, so we can call it y dash, or the new y-coordinate, is calculated by taking the original value for y, which is negative root 3, and then multiplying it by cos of the angle of rotation. Now, remember, we are rotating through 210 degrees, but it is in a clockwise direction. So I'm making it minus 210. However, I can then add 360 to the 210 degrees, and that then makes it 150 degrees. It's the same thing. All right, then a positive sign, and then we use the x-coordinate of our original point. My original x-coordinate was minus 2, multiplied by the sine of the angle, again, minus 210, because it's clockwise, but I add 360 degrees, so this becomes sine. I wrote cos twice here. Can you believe it? Let's cross that out. And then it's minus 2 sine 150. And without going to all of the trouble of all of the thousands of steps, my y-coordinate is then a half. So then that means that my original diagram was correct, because I've got a positive x value and a positive y value, and I am ending up in the first quadrant. So that seems like more or less the right thing. Right, Indiana, tell me how are things looking out there? Less confusion, more questions?
No, well, I think we've actually had a lot. People saying they actually are understanding, which is fantastic. So, board or no board, everyone is understanding. Fantastic. Let me have a look here. Njabulo says, is the answer value an X or Y value? I mean, the answer 1. Does that make sense?
So let's talk about that. What we've done over here, the first line, they have moved the 2 across, isn't it?
Oh, just go back.
Okay, the first line, the 3√3/2 is the x coordinate after my rotation, and the half is the y coordinate after my rotation. I tend to do them separately, so I write down x dash, or the new x, then I'll write down the formula from your information sheet if you want, substitute in, get the new x value. But what you can then do, if that makes more sense, is in the end you can write it as a coordinate. This is 3√3/3, over 2 rather, and a half. So that's the x value and the y value. So I've calculated both. Okay, have we got time for a quick break there, Indiana?
We do. But maybe we can quickly do Yvonne's quick question. It says, what is the formula for clockwise rotation?
Okay, what I'm telling you, Yvonne, is use the formula that I've given you on the board. I'm going to put it on after the break again. Always use the same formula. I think that's the easiest. Otherwise, people get confused. And just remember that if I say 60 degrees anti-clockwise, you just substitute 60 degrees in the place of alpha. If I say 60 degrees clockwise, just make it minus 60 degrees, and then you'll never go wrong. Then you don't have to be insecure about which formula. Just use the first formula on your information sheet, which is the one that I've been using. Positive angle for anti-clockwise rotation, negative angle for clockwise rotation. Easy as that.
Fantastic. Guys, let's take a quick break. I think when we get back, we've got about 15 minutes left to the show. So please get your questions in if there is anything that you are struggling with. Please make them relevant. Try and make them smart. Anything that Liesel has been discussing and you're not understanding, you never know. There might be 100, 1,000 other learners out there that are struggling with the exact same thing. No such thing as a silly question. And when we get back, we'll finish the show off with some of your questions. Cannot wait. See you then. Hi guys, and welcome back to Learn Extra Live. This is our first day back since it's been Easter holidays, and gosh, did we miss all of you so much. So I'm very happy to be back, and I think with that we should give away something a little bit more special. I don't know, it's about to fall onto the floor. Okay, so this is what it is, guys. It's an easy label printer. Create your own original labels anywhere, anytime. So you can, label your cat, label your dog, all of that. Thank you to Cassia for giving us this away. Supports labels. Very cool. But without further ado, I think it's more important that we get onto the lesson. This will be given away tomorrow after the matric show. Guys, best posts, best questions will win you this. So without further ado, I think let's get back to Liesel. I think she's got lots to teach, and we've got lots of questions to get answered. Get those questions in, facebook.com/learnextra and @learnextra. Liesel, take it away.
Okay, guys. So we've spoken about the clockwise, anti-clockwise issue now. We've spoken about the formula. Somebody asked much earlier on in the show, is it possible to calculate the angle of rotation? Yes, it is. That is hard-ish, though. In order for you to calculate the angle that we rotated through, obviously you need to have the original point as well as the new point. So I'm going to go through the method to do that in a second. Just to clarify, I'm going to write down the formula again. I say right, hoping that I can write. Okie doke. So the new x and the new y coordinate is calculated as follows. This would be the first formula on your information sheet. Right. So to get the new x coordinates, we say the x value of the original coordinate multiplied by the cos of the angle of rotation. And I said to you guys earlier on that probably the easiest is to use the same formula, and if you have a Anti-clockwise rotation, a positive angle if you have a clockwise rotation, a negative angle. It's merely a directional thing. Right, so let's try this again. Okay, so cos, okay, let's rub this out and start again. So we're going to say the original x coordinate multiplied by cos of the angle of rotation minus the original y coordinate multiplied by sine of the angle of rotation. Now this part of the formula so far gives us the x coordinate. So that is to get the new x coordinate. So I'm going to do it like that. And then I'm going to put a semicolon. And now the following part of the formula is to get the new y coordinate. And that is ya cos alpha plus xa sine alpha. Okie dokes. Right. Now, I don't know whether we're going to have a chance to finish the entire thing, but I am going to at least attempt it. So what we've got here, and I'm just going to draw a picture because that does speak 1,000 words, is we've got an original point A, which is x is minus 12 and y is 6. Okay, so x is negative 12 and y is 6. Right. Then we have a rotation taking place, and the new coordinate of A is x is minus 11, y is minus 6. So let's, again, the sketch really quite important if you just want to orientate yourself. Okay, so let's say somewhere over here. So minus 12 and minus 6. And we are now asked to calculate this angle of rotation. Right. Now basically, guys, all we need to do is we need to substitute our information into the formula. Now I'm going to start off with the x part of my formula. So what I'm going to do is I'm going to use what I'm underlining over there. Okay. Now, the formula says to get the new x coordinate, we take the old x coordinate multiplied by cos of alpha, whatever. So I'm now going to say, right, my new x coordinate is negative 12. Right? Multiplied by cos of my angle, and I don't know what that angle is. So I'm going to say, sorry, guys, let me just start again there. I'm confusing myself here. Okay. So my new x coordinate is minus 12. So I'm going to say minus 12 equals minus 12. Indiana, we're going to have to start asking our pupils to do this question for us on their pens and paper because this is not going well.
Well, that's okay too.
Again. Yeah, so minus
too
12. Right, let's just extend this page a little bit. Maybe we've just got a gremlin over here. Okay, so now I'm going to say negative 12. That's my new x coordinate. Oh my goodness. I do not know what is going on here today. Right. Okay. Right, let's start again. Minus 12 equals. Right. Now going back to my formula, the new x coordinate equals the old x coordinate cos alpha. Now the old x coordinate is also minus 12. So I'm going to say negative 12 cos alpha. Remember now, guys, I don't know what my angle of rotation is. So it's not a train smash that's not filled in. Looking at the rest of the question, looking at the rest of the formula, the new x coordinate is calculated by old x coordinate cos alpha minus old y coordinate sine alpha. So my old y coordinate is 6. So that's minus 6 and then sine alpha. Okay. Now this gives us our first equation. we've got cos in it and we've got sine in it. It's going to be like doing a simultaneous equation question, where basically, in the end, I'm going to work with sine and cos as if it's x and y. Right, so what I'm going to do now quickly is I'm just going to simplify this equation a little bit. So I'm going to divide through by 6. So that becomes minus 2 is equal to, now remember I'm dividing throughout by 6. So minus 2 is equal to minus 2 cos alpha minus sine alpha, because of course 6 divided by 6 is 1. And what I'm then going to do is I'm going to highlight this guy, keep it aside, I'm going to say that is equation 1. That is the first equation that I'm going to use in my simultaneous equation type setup. Right. Now, you might have guessed this correctly. I'm going to repeat exactly the same process using the y. So looking back at our formula, the formula says to us, to get my new y coordinate, I need the old y coordinate, cos alpha, plus the old x coordinate, sine alpha. So I'm going to repeat exactly the same process now for my y's. So I'm going to say the new y coordinate is minus 6. And I'm going to say minus 6 equal. And you guys will notice I also keep on looking back at the formula because I also forget. Minus 6 cos alpha. Right? Then the old x coordinate. Sorry, guys, let me just start again. I'm doing the same thing over and over again. Okay, the new y coordinate equals. Okay, so the new y coordinate, minus 6, is equal to the old y coordinate multiplied by cos of the angle. So the old y coordinate was 6. So I've just left out the 6 over there. Plus the old x coordinate, which was negative 12. And sine alpha. Now basically what then happens is we've got two equations. I can also simplify my second equation somewhat by dividing through by 6, and I can get, by minus 6 in fact, I can get that cos alpha is equal to 2 sine alpha minus 1. So all I've done with my second equation is I've simplified it somewhat. Right. Now, we're probably going to have to leave this for you guys to do on your own. But basically now what happens is I've got one equation in terms of sine, and I've got one equation in terms of cos. Now things are starting to look a little bit untidy here, so I'm just going to clean it up a little bit. Hopefully we will have time. Indiana, how are people feeling out there? Is the second type of question just the pits, or are we understanding?
I think we are understanding. Everyone seems to be understanding. Let's have a look. Noxipedia is waving at Kashifa, which is always fun, and waving at us, so I'm waving back. Let's have a look. They seem to be good so far.
Well, that's excellent. So
yeah, that's what we'd like to hear.
Let's have a look at our two equations again. So it's minus 2 cos alpha just when I start thinking my pen gremlins are sorted out, it starts again. So minus 2 cos alpha minus sine alpha equal to minus 2. That was my first equation. My second equation I managed to simplify just by manipulating to cos alpha is equal to 2 sine alpha minus 1. Okay, now this is the important bit. Equation 1, equation 2. What I'm going to do now is I'm going to substitute equation 2 into equation 1. So what I'm going to do is, in my first equation, I'm going to replace the cos alpha with 2 sine alpha minus 1. So let's have a look at how I do that. And you can maybe just write a little note for your teacher. So I'm going to say minus 2. So where that cos alpha is, I'm putting a bracket. Okay? I'm trying to eliminate one of my variables. So instead of cos alpha, I'm putting 2 sine alpha minus 1. Okay. So that's what I've done over there. That has been replaced with that. Then I've still got the other minus sine alpha, and that's equal to minus 2. Now, guys, you must remember that the rules of algebra always apply, so don't think of the sine alpha really as anything that much different than x's and y's. So I'm just going to multiply out this bracket. So I'm going to say minus 2 times sine alpha is minus 4 sine alpha. Okay, and then minus 2 multiplied by minus 1 is plus 2, then minus sine alpha equal to minus 2 again. So in this equation, I have now only one variable, and that's my sine alpha. So now what I'm going to do now is I'm going to say minus 4 sine alpha and minus sine alpha are like terms. That's like having minus 4x and minus x. So that together gives me minus 5 sine alpha. Then I'm going to take this 2 to the other side. It's going to join the minus 2 on the other side. That's equal to minus 4. Right. Now, remember, what are we doing here, guys? We are trying to find the size of an angle. So now, if I isolate sine, I can say sine alpha is 4 over 5. And then, on your calculator, you are going to go shift sine of 4 over 5 or of 0,8, whatever you like. The question, by the way, did say that our angle is an acute angle, and you're going to get an angle of 53,13 degrees. Okay, that might seem complicated and it might sound like a lot of writing. It really isn't. I said my new x-coordinate equals old x-coordinate cos alpha minus old y-coordinate sine alpha. I had the old and the new coordinates, so I could get a first equation in terms of sine and cos. Then I did exactly the same thing for the y. So I said my new y-coordinate equals, and I substituted into the formula. So then what happened is I generated 2 equations. Both of those equations had sine alpha and cos alpha in it. Then what I did is I took one of my equations, in this case it was the second one. I made cos alpha the subject of the equation. I said cos alpha is 2 sine alpha minus 1. Then in this equation, instead of cos alpha, I replaced it with 2 sine alpha minus 1 because that way I eliminated one of the variables. It's a simultaneous equation. Then I multiplied out, I used all the usual rules of algebra, and I isolated my trig ratio. I said sine theta equals 4 over 5, and then I bear in mind that what I need to do is I need to find the angle, so then shift sine of my angle. So guys, old coordinate to new coordinate angle of rotation. We've got 3 things involved here. The easiest type of question is if we are given the old coordinate, we are given the angle of rotation, and we are just asked to get the new coordinate. That's a relatively straightforward question. When we're faced with a question like that, remember, just use the same formula that I've been using throughout. Positive angle for anti-clockwise, negative angle for clockwise. Right. The second type of question is where we are given the original coordinate and the new coordinate after the rotation, but the angle of rotation remains a mystery. Remember, write down x equals, and your x part of the formula, y equals, and the y part of the formula. Substitute in your information, simplify those 2 equations, and then just as if you are doing a simultaneous equation in terms of x and y, what you need to do is get only sine or only cos. And finally, at the very end, you're going to use the shift sine or the shift cos button, as it may, on your calculator to get the actual angle of rotation. Guys, we've had a hectic night tonight, all sorts of things working against us, pens not working. However, I hope that what we have tried to explain to you here has come across, the best way to make sure that you can do this is just to practice, right? Plenty of questions, and don't just do one or two. You've got to do lots to make sure that even in a pressurized situation, you keep calm. Right, Indiana, finally over to you before we end the show.
Can you believe it? First day back, first day done. Shows go fast. Tuso also said it's good, you just need to focus and concentrate, and once you do that, it's much easier. Guys, let's see if our cameraman can quickly do a quick pan on this awesome wonder. This is a labeler that we're giving away. Please watch for tomorrow's show, grade 12, we're giving away at the end. And guys, thank you so much for learning more, for learning extra. Don't forget, we're on facebook.com/learn extra, also at learn extra. We had such a fantastic show, and have a fantastic evening. See you same time, same place next week. Bye guys.